On geometry, unit 10, day number 2, we're looking at the volume of prisms and cylinders. We're discussing what the formula for the volume of a prism is, and that's the area of the base. The capital B stands for the area of the base. The area of the base might be a rectangle. It might be a hexagon. The H in our formula is the distance between the bases. So our formula for volume is capital B, and that will work for any type of base. You got to find the area of the base, and then the distance between the bases.
Why that instead of height?
When we look at the volume of a cylinder, the volume of the cylinder is very much the same formula. It's a capital B times H. But in a cylinder, the capital B is always the same thing. The base of a cylinder is always a circle. So we're able to call that pi r squared times H. So we have the same formula as we would with a prism. But with a prism, we don't know if the base is a rectangle, if the base is a hexagon, is a triangle. But in a cylinder, you always know the base is a circle. So we have the area of a circle. We have the distance between the circles. You can call that height, but if it's on its side, it gets a little confusing. So it's the distance between the circles. And R in your pi r squared, R, of course, is the radius. So the volume of a cylinder is pi r squared, that's the area of the base, times the height, which is the distance between the bases. Nice. All right, so with example number 1, remember, this here is considered a prism because you have rectangles for sides and you have 2 bases. The bases in this case are triangles. These triangles are relatively easy to calculate the area because we know 2 sides are perpendicular to each other. So we are going to say the volume equals the base times the height, because that's what it is for a prism. In this case, the B is the area of a triangle. And the height, the H, is the distance between the triangles. So that's what your different values are going to represent. So the base is going to be half. Now we use a small b for base times height. This is of the triangle. Of the triangle, the base could be called 3, and the height could be called 1. And we're going to get an area of the triangle as 1.5. And these are feet squared. So when we come over to the volume, we take this 1.5. All right, all right. For the volume, we're not done. For the volume, we take the 1.5 feet squared, because that's what we calculated from the base times the height. And what are we going to multiply that by? We're going to multiply that by the distance between the bases, which would be considered our height. So we're going to multiply that by 2, and those are 2 feet. So we have 1.5 feet times 2 feet, which gives us 3 feet. And the feet, notice, we have a feet squared. And in this case, we have a feet to the first power. So that's a total of feet cubed. So volume is always a cubic unit. It's always a 3-dimensional unit. It's how many like ice cubes could physically fit inside there. If each ice cube was a foot by a foot by a foot, okay, how many of those could fit inside here? Sometimes you got to melt it down to get it to fit perfectly, but it would still completely fit in there. Okay, next we're going to look at a cylinder. And we know that a cylinder is the volume is pi r squared times the distance between the 2 circles. In this case, they're asking for the exact volume. So when they say exact volume, they're talking about using pi in your value. Don't use your calculator, don't get a decimal. So for us to calculate the area of the circle, we need the radius. They give us the radius. So pi 5 squared times the distance between the circles, which is 6. So we have 150 pi, and these would be meters cubed. That would be considered the exact volume of our cylinder because it uses pi and we didn't round numbers. All right, if you look at number 3, we see a cylinder, but this time they are giving us what the volume is. So we've got to work backwards. So really pay attention. There was a question on our previous test that had area of the figure. And a lot of you just took that area and you squared it because you treated it like a radius. Okay, but they give you the area. You got to stick that in the correct location of the formula. Here, they're giving us the volume. So we know that the volume equals pi r squared times the height. The volume of the right cylinder is shown is 1253. So we're going to put the 1253, 1,253 in place of the volume. The radius is the x value, and that's what we're trying to calculate. And the height between the bases is the 10. So now we want to solve for the x. We want to get the x by itself. So to do that, we're going to divide by the 10 and the pi. We can do that all in one step. Divide by the 10 and the pi. We do that to both sides. So when you do that with your calculator, you have to be a little careful. We have to divide, and it might be safe if you use parentheses, because you want to be sure that you have your 2 and the pi being divided at the same time. If you want to divide each one individually, that's fine. Divide by 2, then divide by pi. That would completely work. Oh, thank you. We talked about 2 and I wrote, okay. 10 pi, that is more correct. And we get 39.88. That is our x squared. So some number times itself equals 39.88. So what are we going to need to do to figure out what this radius, this x value is going to be? Take the square root. So we're going to take the square root of 3988. That's a vacuum. So we have the square root of 3988. And that will come out, yep, go ahead. Nice, 6.32. Those are centimeters. And that would be your radius. Now notice the centimeters. Centimeters are not cubed. Centimeters is a distance. All right, so it's just a single unit. It's not squared, it's definitely not cubed. So here we're talking about right prisms. We've used that terminology already. Those are ones that are standing straight up. All right, that would be considered a right prism or a right cylinder. Even if it's slanted, right? It's like taking your pennies, and if you slant the pennies off to the side by stacking them up, not on exactly on top of each other, but it slants over, it is still going to have the same volume as if it was straight up. So you need to know what the height is, and you need to know what the base is. So if two solids have the same height and the same cross-section area at every level, then they have the same volume. So what we're going to do, looking here, we're going to find the exact, and we know what that means now. Exact volume is going to have the pi in it. So find the exact volume of the oblique. That just means that it is slanted. The oblique cylinder. So what we need to do in these cases, this is the slant height. We need to know what the actual height is, the perpendicular height. So if you take those pennies and you lay those pennies off to the side, if these were made of pennies and it wasn't straight up and down, this distance here, 18, would be different than perpendicular. And we know that because the hypotenuse is longer than the leg, right? The hypotenuse is the longest side. So what we're looking at here is a 30, 60, 90 triangle with a hypotenuse of 18. If the hypotenuse is 18, we know that the short leg is going to be half of that. And we know that the long leg, the actual height of our figure, is going to be root 3 times that. That came with our special right triangle rules when we did right triangles. So now we should be ready to use volume equals pi r squared times the height. So our radius is going to be half of the diameter. Don't make the mistake and use the 9. The 9 is the distance that we're out. We've slanted over. We don't want that distance. We want the radius of the circle. So that is half of our 12. And then we know that our height is 9√3. So think about where those numbers are coming from. Just writing them down isn't quite enough. That's the easy part. Understanding where they come from is more the challenge. Why didn't we use the 18 in the formula? Why didn't we use the 9 in the formula? So we can calculate out the rest here. The volume equals pi. 6 times 6 is 36, 9√3. If we multiply 36 times 9, that's going to come out to be 324. Then we would have the pi symbol. And if we're not going to be using rounded values, we would not want to know the decimal of the square root of 3. So you put your values in front of your square root. So you get 324 pi root 3. And this is volume, so it's millimeters cubed. So you go ahead and find the volume of our right rectangular prism. And if you're watching the video, you can pause it, try it on your own, and come back and watch it get completed. Check your answers. Good questions. We have the volume. In this case, is the base times the height. This is a rectangular prism. So our base is a rectangle. Most of us would probably consider the base to be the shape on the bottom. So that's the 11 times 4. And we also have the height. So that's the distance between the bases, or that's the distance perpendicular to the base. And that is going to be 5. So we get 44 times 5. 44 times 5, 220. These are meters cubed because the 11 would have a meter on it, times the 4 that has the meter on it, that's squared, times the 5 that has a meter on it, that's cubed. So the volume of this, let's call it a fish tank, would be 220 meters cubed. That would be a pretty big fish tank. All right, this one's kind of neat. All right, we are going to calculate the exact volume. So we know that this is a cylinder. So we have pi r squared times the height. We know that the radius is 6 and the height is 9. So we get 36 times 9. That comes out to be 324 pi. And these are feet cubed. You want to leave the pi symbol on there if you're talking about the exact. You don't want rounded values. Two more questions. Now, in this case, this is an oblique prism, an oblique triangular prism, because the bases are triangles. Since the triangles are bases, you know, to calculate the area of the base, we need to be perpendicular. So sometimes a triangle can be tough to work with. But in this case, these are perpendicular to each other. So the 5 and the 9 are perpendicular to each other. So we can find the area of that triangle. Then we can times it by the perpendicular height. Not the slant height, but the perpendicular height. So in this oblique triangular prism, we're going to find the volume by half 9 times 5 times 8. That's 40 times 9, which should be 360. And when we take half of that, we get 180. We're taking half because a triangle is half of a rectangle. So if we did length times width times height, as we did, that's when we fill up the fish tank. But we're only filling up half the fish tank because this is a triangle. So that's why this is a half, but other ones were not. Okay, last one. Last one. What do you notice is different about this last one? We are going to be working backwards. And the key thing to realize is that little symbol next to the 200. That helps out a lot. The pi symbol. 200 pi is the volume. That's going to help out because when we take and solve for the x value, which is the diameter in this case, we're going to have to start out finding the radius and then determine the diameter. But when we do that, we're going to have to divide pi's and it will cross out. It'll be very nice. So the volume is pi r squared times the height, because this is a cylinder. The volume is 200 pi. We don't know what the radius is yet. I'm going to leave it r and not call it x because x is the diameter, r is the radius. So I'm going to try to keep my units correct. And my height is 8. So if I divide by 8 pi, the 8's cross out, the pi's cross out. Okay, that gives me 25 equals r squared, and r is going to be the square root of 25, which is exactly 5. So if the radius is 5, the diameter equals 2 times the radius, which is 2 times 5, which is 10. That's our x value. The diameter would be 10, and these would be 10 centimeters. The x value is all the way across the circle through the center, so that is the diameter.